What's up everybody, it's your boy Berto. In this video I want to show you guys how to set up a static IP, especially to Connected Components Workbench. And you'll notice that instead of kind of going through the boot P GUI, instead on Connected Components software itself, you can actually set up the static IP. So not only can you not just set up your HMIs, your PLCs, or your drivers, but also set up an actual static IP tool. But anyways, to cut it short, we're going to go ahead with this video and I hope you guys enjoy this.
Hello everybody and good morning. Today I wanted to show you guys how to set up a static IP with the Micro850, mostly for the Micro800 family. I know that in the previous videos I had this on an APIPA number due to security reasons, but there's three main reasons why you want to give it a static IP to either your HMI, your driver, or your PLC, SCADA device, any of this sort. Is because well, let's say for one thing, you're in an industrial environment and you have multiple machines that depend on this PLC. In order for it to, for things to not malfunction, or to also not always having to depend on a dynamic IP to give it a new release of a new IP address, with that static IP, it can continually run with its functions, with its other devices that's already been programmed to run with. That is one of the main reasons why a static IP is so important to have, and also having it in a private IP as well. Imagining having it on a public IP, well, one of the first things, it's going to be costly, and the second thing is that there's going to be a lot of security issues that can go around it. Believe it or not, through this classes I've been learning how PLCs are very vulnerable in their state of mind. You won't believe that many countries are trying to find ways to hack through a PLC. So this is one of the second reasons why it should never be on a public IP number. Also, a third reason why is that basically you can always identify which PLC it is, because you know it will always be that number. It's easier to ping to that PLC, and it's just a far more easier way to have it more secure in a way. So I guess the third reason is the same as both reasons, but it's always very important to set up a static IP, and also readout times are much more efficient. So one of the first things that you're going to notice here is that we're going to have the Micro850 page pulled up, basically when we set up a program through Connected Components Workbench. And then what you're going to do is that over here when you click on the Micro850 tab, we're going to go under its tree, and then over here under controller trees, we're going to go under to the Ethernet. And then if you double click here, like I'm already am, we're going to see that it's already here. And also one of the first things to do actually when you're going to set up the static IP is to actually connect it to a USB from your laptop or computer to the device itself. This is way it's going to be much more easier, and as you can see over here on my right side of the screen under below connect, it's already connected to it and already set up a path to that PLC. Now, over here on the Ethernet part, one of the first things you're going to see here is that it's already marked as obtain IP address automatically using DHCP. So it's going to automatically try to get a dynamic IP. But you can find actually issues when you actually try to put this on a switch that's already connected to a router. You know what I'm saying? If it starts giving out an IP address and there's going to be a renew, imagine your programming has to depend on that IP that it used to have, but now it's in a different new IP. So this is another reason why we need to set it up as a static IP. So in order to do this, we're going to have to put it on configure IP address and settings. So you want to check that. Another thing, and as you can see, a red line is going to be on the box here that's going to indicate, hey, so you're going to set up a static IP to it. So we're going to go ahead and do that. Another thing is that we wanted this port state to be enabled, so we wanted to communicate through that Ethernet port, and also have it to auto negotiate speed and duplex mode. If you want to mess around with that, I think it gives you around 100 to 1,000 megabits per second. That's your option, but my option for you guys who are starting out is to just let it at auto negotiate speed and duplex mode, and it does a very good job. And then now here comes the good part. So as like I said before, you want to set this as a private IP number, but at the same time you don't want it to be a private IP that's already on another device. it can't be the same. So you have to have this different. So let's just say, for example, you had a box with an HMI, a PLC, a driver, and some other devices that has to go along that can communicate to each other. One of the first things you want to do is kind of like think logically of saying, hey, if this is going to be 192.168.1.5 for my HMI, then the PLC is going to be a 6 on the 4th octet, and then the driver could be a 7 on that 4th octet as well. This way, when the communication between those devices can communicate to each other, they can identify which one is which through its MAC address and through the switch. Alright, and also this way you won't have conflictions. Now, for this example, I'm going to use a 192 private number, so it's going to be a class C number. So I'm going to go ahead and put 192.168.1.3. Alright, and that's the IP address for that. And then for the subnet mask, you're going to have it on a 2555 backspace 2555, 2555 and 0. So your 3 octets are going to be 255s, and the last octet is going to remain 0. And then your default gateway, this is actually one of the most important steps. You're going to want that as what it's being able to go back to the firewall and through the router. So you're going to actually, one of the best ways to find out what is your default gateway is going to command prompt on your laptop or on your computer and just put ipconfig or ipconfig all. You can actually look it up, or I'll actually pull this up on the page on this video. And once you do that ipconfig, you just have to look at through your Ethernet card of where it's being communicated, where you receive connection to the network, and you will find that gateway address. So for mine, for example, I'm having mine as 192.168.1.1. So I'm going to go ahead on my next tab here and put 192. Oh wait, there we go. 192.168.1.1. So okay, so now that we have that, we're going to be able to connect to it. So we're going to go ahead and connect to this PLC. And you're going to have a couple of warning signs that is going to come up on the screen in a couple of seconds. In this background, I'm in school at the moment, but it's early morning, so I'm taking advantage of this. Let's see. So you're going to go ahead and download the current project to the controller. So we're going to go ahead and do that. And as you can see here under the Ethernet, right here on my mouse, we already see the settings to project control. Oh wait, hold on. The warning signs just came up. We're going to go ahead and download with project values. Do that. Hold on for a second. Okay. And actually, I think it already downloaded that IP address to that PLC. But just something that you might have noticed on that screen here a couple of seconds ago is that it gave us a warning that said, hey, you're basically setting this IP address to this PLC. It's a different configuration. Would you like to save it to the controller? You want to put yes onto that. You just have to click on that Save to Controller tab, and it will automatically save that IP address that you gave it to that PLC. And then we're going to go ahead and see if that actually worked. So I'm going to close that out. And let's see over here. We're going to go ahead and go to Micro800. And yes, it did actually. It actually saved that IP address. But to make sure that it actually did, we have to go into RS Links logic. And instead of connecting it from USB to the PLC, we're going to have to connect it to a switch. And then I'm going to run RS Links Classic. And then we're going to see from there if it's connected to that PLC, and we're able to communicate either by Ethernet to that PLC straightforward or through a switch as well. So just give me a couple of seconds and I will show you guys how that's done. Excuse the mess here real quick, but just to show you guys. See, I got one connected to the laptop. The NIC card over here, and then I got it to connect the other switch to the PLC right here. So it's pretty simple. Not a whole lot of infrastructure needed. Just have a a good switch nearby, and just configure it from there. Alright guys, so we're going to go ahead and validate if we're actually talking to this PLC. It actually saved the IP address. As you can see here, it's 192.168.1 and 3. And so we now know that this PLC is communicating to our computer, and one of the ways you can actually test this is by pinging it. So as you can see here, I already done a ping test, but just to show you guys, you just do ping, and then you're going to put in the IP address that you put on 192.168.1.3, and then it's going to start talking, and then it's going to start to reply back to us. And it's not timing out, so that's good. And as you can see, it's the time talk to live is it's in the appropriate amount, so this is good. And actually you can also do a arb-a and actually see the IP address and the MAC address right here. Even though the type says it's on a dynamic, you can actually set this on command prompt to actually say that it's under a static IP, because it is on a static IP number since you already gave it an IP address. And usually in an industrial environment, they usually have what we call a reservoir of IP addresses that they keep, so that whenever they have to give it to a certain device to attain that IP address, it will always have that IP address. So you just have to go to your administrators and your IT specialists to actually give you that IP address for that purpose. So we already know we're able to communicate to it. But one of the things that happened is that when sometimes we don't set up right the NEC configuration or the network card in order to communicate to it. So I'm going to show you guys how to actually do that. You're going to go right here on this bottom left tab right here, and it says where it has the internet and the network access, and you're going to open network and internet settings. So we're going to go ahead over here, and then you're going to go to change adapter options, excuse me. And once we open up, you're going to go to the properties here. You're going to right click on Ethernet properties. Then you can go to Internet Protocol version 4. And then when you double click that, or you can actually just click on properties after you have that highlighted, over here, instead of it having it where it says obtain an IP address automatically, which refers to whenever you're already hooked up through Ethernet or through the Wi-Fi, it'll just give you an automatic IP address dynamically, and it will renew the release every time it expires, or either gives you the same one or a different one. But however, instead of doing that, you can set up to where you give yourself a static IP number that's different from your device. So as you can see here, connected components on the RS links, as you can see, it's under a 3 as the 4th octet. So that it makes it different from the PLC static number to your NIC card number, which will be 1.5. So then you want to make sure you have the correct subnet mask. So since this is a class C, you're going to have it 22255s, and then the last octet will be a 0. And then of course you want to make sure your default gateway is the same way it is under the same network private communication that you're under. You want to make sure that has the same firewall gateway as the one for the PLC as well, so you guys are communicating to each other. Then you're going to click on OK, and it should go on pretty good. Now you may notice that as you can see here on the bottom screen, that has the yellow triangle with the exclamation mark. That's not to be worried about, because you're not actually accessing the network you're not accessing the network per se to Chrome and all that good stuff, because you're just only trying to communicate to that PLC. Now later on, however, you can connect your switch to where you can go through and communicate through a network, and then through a Wi-Fi, and then even on the advanced PLCs, like the control logics, you can actually go into that PLC itself and find the web application page for it and actually do some settings under that. But of course, that'll be on another time to kind of show you guys that. But anyways, so that's pretty much it of how you actually set up a static IP. And knowing that you are communicating to it. And one of the cool things too is that you can actually see pretty cool features about the properties of it. Actually, let me see if I can actually pull this up right here. See if I have time. And you can see the device properties gives you the firmware version that it has on, the product type, and then also, let me see if I remember which tab it was. I believe it's under module statistics. Let it pull up. Yes, there we go. So actually here you can actually see other things, like it'll give you if there has been collisions or errors, and seeing how many packets it's been sending back and forth from your PC to the net through the PLC, and that's actually being communicated right now through a switch. And I'll have a picture of that, of the setting that I have it under. So, and anyway, so that's pretty much it of how you actually set up a static IP for Connected Components Workbench. So I hope that video you guys found was useful, especially for Connected Components Workbench. And on my next videos, I'm going to be messing with some SCADA. There are types of PLCs, but you can actually hook up some actual cameras on these SCADA devices. So I'm going to have a fun time with that. But also I'm going to set up another video of how to use the BootP GUI DHCP application that would originally you would put to set up a static IP. But for this video, I just wanted to show you guys how to do it the easy, much simpler way through Connected Components Workbench. And if you're able to actually use a software application for that PLC and just to set up a static IP through there, why not use it? I mean, it's just another way of training, another way of just setting a static IP. And of course, you know, set it up to a private IP. Don't let it be on a public IP address, because that will ensure much more security. And also, hopefully on my future videos, we'll be talking about how to secure port numbers, because, you know, a lot of the advanced PLCs now, you can go through your web application or through the web and just see your system there. But well, I won't say a hacker, but most people that are trying to find ways to actually take in information about your PLCs or even attack it would just have to just find the IP address and just has to make sure that that some of the port numbers are actually open. So it's stuff like that we're going to learn on throughout these next videos. Hopefully that I'll be posting in a couple of weeks. So thank you guys again for watching this video, and I hope you guys have a wonderful day. Thank you.